Hello students, from today we start to solve the IB Math AHL May 2025 paper 3 time zone 2. And today we'll be solving the question number 1 of this paper. You will be getting the solutions for the other questions from the other past papers in form of playlists on my channel NS Online Math Tutoring Classes. You will also be getting playlists where the solved past paper questions will be available based on their topics. I'm Nilanjana Sanyal. I'm an online IB Math AHL level tutor. My phone number and my website address are displayed at the bottom of the screen. So without any further delay, let us start to solve this question number 1. The maximum mark is 28. Following question explores features of a family of curves. The family is then linked to a homogeneous differential equation. That means the ones that we solve with this substitution y equal to vx. Let's see what is the question. What are they asking for? Okay. Consider the curve given by y equal to x times x square minus 16 over x square plus 16. And subpart is having 3 further subparts. The first subpart I is asking for sketching of the curve of y for x values greater than or equal to negative 10 but less than or equal to positive 10. And it is carrying just a single mark. Okay, so we can use the calculator, the graph, and we have to input the expression. It is x square minus 16 over x square plus 16. Enter. And it is from negative 10 to positive 10, the x values. And of course, I need the y values when x equal to negative 10 and when x equal to positive 10. For that, I can use the graph trace. Yeah, from when x equal to 0, y equal to 0, that is obvious. And because you are having this x. And now when x equal to negative 10, so negative 10 enter, and it is negative 7.24138. So up to 3 significant figures, I can take negative 7.24. Okay, so negative 10 and negative 7.24. And what will be the coordinates? Y coordinate when the x coordinate is 10, it is 7.24. Okay, so 10 and okay. So these are the 2 points, and now we have to know the maximum, minimum, and the zeros also in order to sketch the curve. So first of all, I come out of the graph trace, and then I can find the zeros, analyze graph and the 0. This one is minus 4, and the other one will be plus 4. And now the maximum and the minimum points. Minimum and maximum. Okay. So now I'll be just copying this graph. So this is the graph that I have sketched. It is carrying just a single mark, but even then I have put, actually this is the way that you have to sketch the graph. You have to give the coordinates of the endpoints. So I have given all the information, but it is carrying just a single mark. So, and it is question number 1, just the starting of paper 3. So if you want, you can just give the sketch also. Okay, and not give the coordinates of the relevant points. Okay, because over here for II and III, you will be needed to give the coordinates of the zeros and the maximum and the minimum points. The only 2 information that are remaining is the coordinates of the 2 endpoints. Okay, so this is A and I. And coming to I, state the coordinates of the points where the curve crosses the x-axis, that means the zeros. So it is crossing the x-axis at 3 points. This one is -4, so it is -4, 0. Coordinates means we have to give both the x and the y coordinates. 0, 0 and 4, 0. Okay. State the coordinates again of the local maximum point and the coordinates of the local minimum point. So maximum or local maximum, it is a local maximum, obviously you see the graph is going up, is -1.94 and 1.20, correct to 3 significant figures. And local minimum will be 1.94 and -1.20, correct to 3 significant figures. Okay. This is the local minimum and this is the local maximum. Subpart B. State whether the function f of x equal to x times x square minus 16 over x square plus 16 is odd, even, or neither. Justify your answer. Okay. So subpart B. What is odd? It is an odd function if f of negative x equal to negative f of x, and it will be an even function if f of negative x is equal to f of x, and it is neither function when it doesn't satisfy this or this. Okay. So let us start with f of negative x. F of negative x, I'll be substituting negative x in place of x. So it is negative x and negative x whole square minus 16 over negative x whole square plus 16. So this is equal to negative x whole square is x square minus 16 over x square plus 16, which is equal to negative f of x. This part is f of x. Okay. So f of negative x is equal to negative f of x. Therefore, f of x is an odd function. Okay. Okay. Now consider the general curve given by y equal to x times x square minus a. Instead of 16, they have taken a general condition a, where a is a positive constant and x is a real number. X times x square minus a over x square plus a. Now subpart C is saying, given that f of x equal to x times x square minus a over x square plus a, prove that f prime of root a is independent of a. That means, first of all, we have to get the expression of the first derivative. So f of x equal to x times x square minus a over x square plus a. Okay. So f prime of x, we will be using the quotient rule. So this one is x square plus a whole square. That this is the easiest part. Now we have to differentiate the numerator. First of all, in case you keep it in factorized form, you have to use the product rule, or else you can write the numerator in this form, x cube minus ax. So the derivative will be 3x square minus a. Okay. So 3x square minus a times the denominator. which is x square plus a, minus the derivative of the denominator, which is 2x, times the numerator, so times x, so it is 2x square and x square minus c. Okay, so now we have to get the value or the expression in terms of a for f prime of root a, square root of a. So therefore f prime of square root of a will be equal to 3 times square root of a whole square minus a square root of a whole square plus a minus 2 square root of a whole square and square root of a whole square minus a over square root of a whole square plus a whole square. Okay. So this is equal to square root of a whole square is a. So 3a minus a is 2a. And this one is a plus a is again 2a. And this part is a minus a is 0. So I'll not be having anything from the second term over square root of a whole square is a plus a is 2a. 2a whole square will be 4a square. And the numerator is also equal to 4a square. So this is equal to 1. Okay. So therefore, f prime of root a square root of a is equal to 1. Okay. Is independent of a. Therefore, independent of a. Shown or proof. Okay. Fine. Coming to Sapat D, it is also having 3 sapats. Show that the first sapat is saying show that x minus 2ax over x square plus a is equivalent to x times x square minus a over x square plus a. Okay. So I have brought the sapat D down. Okay. X minus 2ax over x square plus a. This should be equal to, I am taking the common denominator as x square plus a. So it is x times x square plus a. That means I am multiplying this. This is what? This is x over 1 and I am multiplying both the numerator x and the denominator 1 by x square plus a because I need the common denominator to be x square plus a. Okay. And I am just writing them together. And this is minus 2ax. Okay. So this will be equal to separating them, this one expanding them rather. It is x cube plus ax minus 2ax over x square plus a. So this is x cube minus ax over x square plus a. Okay. Shown. So I. Hence, so we have to use this. Hence, determine the equation of the oblique asymptote to the curve. What was the curve's expression? Let us see that. This was the curve's expression. And how can you say that there will be an oblique asymptote? We can say that there will be an oblique asymptote because the degree of the numerator is x cube. If you expand this, it will be x cube minus ax. So the degree of the numerator is 3. Okay. And the degree of the denominator, it is a quadratic expression. So the degree of the denominator is 2. Therefore, the degree of the numerator is more than the degree of the denominator. Hence, we will be having an oblique asymptote. So now comes the question that what will be the equation of the oblique asymptote. Fine. So let us see how do we get the oblique asymptote's equation. I'm just taking another particular case. Suppose we have the rational function expression as x squared plus 1 over x minus 1. Again, the degree of the numerator is 2 and the degree of the denominator is 1. So we will be having an oblique asymptote. What will be the equation of the oblique asymptote? We have to perform the algebraic long division. X minus 1 will be the divisor and the dividend will be the numerator, but you have to be careful about having all the powers of x. The term containing x is missing in this numerator expression. So I'll be writing 0x and plus 1. Okay, the numerator in this case, it is the dividend. The dividend should be having every power of x starting from the highest power. And then we will be dividing the first term of the dividend by the first term of the divisor. X squared divided by x is x. And then we will be multiplying every term of the divisor by this. This is the first term of the quotient. Okay. So x times x is x squared and x times negative 1 is negative x. And we will be subtracting. So the signs will be changing. These two will be cancelling and we will be having x and plus 1. We bring this one down. And now the divisor is x minus 1 and this is the new dividend which is x plus 1. Both have the same degree, that is equal to 1. We will be stopping the division when the degree of this is the remainder. Now this becomes the new dividend. This has a degree less than the degree of the divisor. But in this case, the degrees are the same, so we have to continue the division. Again, we will, now this becomes the new dividend, so we'll be taking the first term of the dividend and we'll be dividing this by the first term of the divisor. So x divided by x is 1. This becomes the second term of the quotient. And we will be multiplying this term of the quotient by with every term of the divisor. So 1 times x, we will be writing the products under the like terms. So it is x and 1 times negative 1 is negative 1. Again, we have to subtract. So the signs will be changing and this will be 1. Okay. So this is equal to 2. Okay. So now in this case, what will be the equation of the oblique asymptote? It will be just the y equal to x plus 1. We will be taking the expression of the quotient. But if we are required to write this, we will be writing this as x squared plus 1 over x minus 1 is equal to the quotient, that is x plus 1, and plus this is the remainder 2 divided by the denominator, that is the divisor. Okay. If you combine these two, let's see what happens. Do we get back to this? Let us see. I'm taking x minus 1 as the common denominator. So x plus 1 times x minus 1 will be giving us x squared minus 1 and plus 2 will be giving us x squared plus 1. So this can be written in this form. Clear? And we get this part which doesn't have any denominator. This will be the quotient of the division. If we perform the long division, this part will be the quotient of the long division. So this will be y equal to this expression will be the equation of the oblique asymptote. Is this clear now? Now you may be able to relate why have I taken up this part. Now I come back to di. Okay, di was x minus 2ax over x squared plus a. The original expression is x times x squared minus a over x squared plus a. Okay, so let me write this: x squared minus a over x squared plus a. This is the original function expression. Okay, and this should be equal to x minus 2ax over x squared plus a. X minus 2ax over x squared plus a. Okay, now you can see the similarity. This, for this case, the degree of the numerator was 2 and the degree of the denominator was 1. And for this, the degree of the numerator is 3 and the degree of the denominator is 2. There is a difference of 1 in both the cases. And this can be written in this form. And this part which doesn't have any denominator forms y equal to this part becomes the equation of the oblique asymptote. So this part y equal to this part which doesn't have any denominator will be giving you the equation of the oblique asymptote. Okay, so hence, because this is saying hence, so you have to use this, and this is carrying just a single mark. So there's no point in doing the long division. If you start from here and you divide x cube minus ax by x squared plus a, you will be coming to this form. But you do not need to do this long division. Okay, so hence the equation of the oblique asymptote is y equal to x. Okay, I. Write down the coordinates of a point on the curve where the oblique asymptote is parallel to the tangent to the curve at that point. Okay, parallel to the tangent to the curve at that point. So the oblique asymptote, since these two lines will be parallel, the oblique asymptote and the tangent, they will be having the same gradient. And what is the gradient of the oblique asymptote? The gradient of the oblique asymptote is 1. Okay, so I gradient of the oblique asymptote is equal to 1. Therefore, gradient of the tangent will be equal to 1 because these two lines should be parallel. And what is the gradient of a tangent? It is the value of the first derivative when you put the x value for the point, the x coordinate of the point where the tangent is to be drawn, and you plug in that x value in the expression for the first derivative of the function, and you get the gradient at that point. So and we know the gradient has to be equal to 1. See over here, you can try, you have got this expression f prime of x, and you can equate this to 1 and you can try to get the x value. These are all x squared, this will be x to the power of 4. Even this will be x squared times x squared will be x to the power of 4. This will also be x to the power of 4. So it will not be a very easy case to find what will be the x value. But over here, we are seeing that f prime of root a is equal to 1. Okay, this was the answer for the subpart C. So from subpart C, we know that f prime of root a is equal to 1. So therefore the x coordinate should be equal to root a. Therefore the x coordinate of the point is root a. And what is the y coordinate? So for that, we again go back to the expression y equal to x times x square minus a over x square plus a. So y equal to x times x square minus a over x square plus a. Now we will be substituting this root a in place of x. So when x equal to root a, y equal to root a, and it is root a whole square minus a over root a whole square plus a. And now you see root a whole square is a minus a. This part is equal to 0. So this is equal to 0. So the y value is equal to 0. Therefore, the point is root a comma 0. Okay. So this is our final answer. Now consider the differential equation x squared dy dx equal to x times x plus y minus y square. X is not equal to 0 and y is not equal to plus minus x. Using the substitution y equal to vx, the differential equation can be written as x times dv dx equal to 1 minus v square. You do not have to show this, but if in case you are confused by looking at this equation, how are we coming to this equation from this equation? Let me show you. They have said that we have to substitute y equal to vx. Okay, so y equal to vx, and we are doing the implicit differentiation with respect to x. So it is dy dx, and we'll be using the product rule. So it will be v when we are differentiating the x, and when we are differentiating v, it is x dv dvx, x dv dx. So we are applying the product rule over here. Okay, and what is dy dx? Dy dx will be equal to, if I divide the entire equation by x square, what happens? It is x, I'm just expanding this, okay, x square plus xy minus y square over x square equal to v plus x dv dx. Okay, and now I'm separating the terms. X square over x square is 1 plus xy over x square will be, one of the x will be getting cancelled from the denominator. You will be having y over x, and since y equal to vx, y over x will be equal to v. So this is v, and this one is minus y square over x square. So this is minus v square equal to v plus x dv dx. And if we subtract v from both the sides, we get x dv dx equal to 1 minus v square, which is given. Okay, so we have now understood how are we getting to this this equation rather. Okay, subpart E, using partial fractions, show that the integral of 1 over 1 minus v square with respect to v is equal to half times ln of absolute value of a times 1 plus v over 1 minus v, where e is a positive constant. Okay, so 1 over 1 minus v square dv. This is the question. Okay, so now we will be using the partial fraction. So let me just get the partial fraction separately. This is equal to 1 over 1 minus, we have to always factorize the denominator first of all. So this is 1 minus v times 1 plus v, which should be equal to a over 1 minus v plus b over 1 plus v. Okay. And now we have to find the values of a and b. So for that, we will be multiplying the entire equation by the denominator, 1 minus v times 1 plus v. So the left hand side becomes equal to 1 equal to a over 1. Okay, let me write times 1 minus v times 1 plus v plus b over 1 plus v and 1 minus v times 1 plus v. Okay, these two cancel and these two cancel. So it is 1 equal to a times 1 plus v and b times 1 minus v. Okay. Now we will be taking one value of v so that one of these two parts be equal to 0. Okay, and we can get the value of the other variable. Not variables, the constants. Okay, so let v be equal to say 1. If v is equal to 1, 1 minus 1 will be equal to 0. So this part will be equal to 0. Then we have 1 equal to 1 plus 1 is 2. So 2a. Therefore, a is equal to half. Similarly, if let v equal to negative 1, then this part 1 minus 1 will be equal to 0. So 1 will be equal to, and this one will be, b is negative 1, negative of negative 1 will be positive 1. So it is 2b. So b is equal to half. Okay. So that means 1 over 1 minus v square is equal to 1 over 2, 1 minus v plus 1 over 2, 1 plus v. Okay. So this is equal to, I can take out half and 1 over 1 minus v dv and plus half 1 over 1 plus v dv. Okay. And this is equal to negative half ln of 1 minus v plus half ln of 1 plus v. Now plus c, you should be having the constant of integration. This should be written in a slightly smart way because you are seeing that there is no c over here and there is this a and there is the half in front. Because there is the half in front, so the constant term that we will be adding, let it also have half so that we can take this half as the common factor out from the three terms. Okay, and let it also have ln because I'm seeing the ln and this is the entire expression. So let me write the c's expression as half ln of a, because if you write it as plus c, you will never be able to come to this form. Okay, so now it is just taking the half out and then I can write this as ln of 1 plus v, and I have not put the absolute value notation for ln of a because they have said a is a positive constant. Okay, so mine plus ln of a I can write and minus ln of 1 minus v. So this is equal to half ln of a times 1 plus v over 1 minus v. Okay, see, a half times a ln of absolute value a times 1 plus v over 1 minus v. Okay, Shown. So, but if, hence again, show that a solution to the original differential equation, that is this one, may be expressed in the form of x square equal to this, where e is a positive constant. Okay, I have brought down the questions. This was the original differential equation, and they had shown that this can be written in this format, where y was equal to vx. Okay, and we are asked to show that one of the solutions to the original differential equation may be expressed. Why one of the solutions? Because e can have different values, can be expressed in this form. Okay, so let us try. F, I'll be taking this differential equation because we have solved the e contained this b, and the question says that hence. So I'm assuming that I'll be taking the help of the support E, and so which contains V. So I'll be taking this differential equation. Okay. So x dv dx is equal to 1 minus V square, and now I'll be separating the variables. So it is dv over 1 minus V square is equal to dx over x, and we will be integrating both sides. And we have seen the integral of this. This was equal to half ln of a1 plus v. So this is equal to half ln of a1 plus v over 1 minus v, and this is equal to ln of x. Okay, and now we are seeing that we need x squared. So first thing is the two ln's can be cancelled, but I cannot have this coefficient, and I also need x squared. So I can do this. And another thing that I have to say is, you may be wondering, why didn't I take the constant of integration this side? I haven't written another plus c because the constant of integration has already been taken in this a. So that is why I have not written another constant of integration. Okay. And since I cannot have any half or any coefficient before the ln, I need to remove the ln because this is not having any ln. So I have to write it without this coefficient. Therefore, I'll be multiplying the entire equation by 2. So I get 1 plus v over 1 minus v is equal to 2 ln of x. Sorry, this should be within the absolute value notation. And since we are asked to get the solution in form of x square, so I can transfer this to the power of x. So this will be equal to 2 ln of absolute value x square. And absolute value x square, I can remove this absolute value notation because x square is always a positive term. The argument of the log function, it has to be a positive term. That is why we use the absolute value notation. But x square will always be a positive term. It is, this 2 will not be there. So doesn't matter what is the value of x. X can be positive or x can be negative, but x square will always be positive. Okay, so this is nothing but ln of x square. Okay, so this is equal to ln of this side is a and 1 plus v over 1 minus v. And now I am having one term on either side of the equal to sign, and so I can equate the arguments of the ln function. So it is a and 1 plus v over 1 minus v, and I have to write the absolute value notation also, and this should be equal to x. Okay, so shown. I have to keep the absolute value notation because x square will always be a positive term. Okay, we are done with subpart F. Coming to the last subpart. Now consider only the case where a times x plus y. Okay, sorry, we are not done because this is having x plus y and x minus y, and I'm having 1 plus v and 1 minus v. Okay, so we have to bring back the y and x. What was v? V was equal to y over x. Okay, so it is a and 1 plus y over x over 1 minus y over x. So this is equal to a and x plus y over x over x minus y over x. Okay, so this x and this x will be getting cancelled because x plus y over x, this is a, there is the a, divided by x minus y over x is equal to a and x plus y over x times x over x minus y. Okay, so these two will be getting cancelled. So therefore, we will be having a and x plus y over x minus y. Now it is shown. So x square equal to this. So now we come to the last subpart. Consider only the case where a times x plus y over x minus y is greater than 0. So we do not need the absolute value notation. Subpart G's question is show that a solution to the original differential equation is y equal to x times x square minus a over x square plus a. Okay, that means we have to basically make y the subject. Okay, so subpart G, since a times x plus y over x minus y is greater than 0, therefore x square is equal to a times x plus y over x minus y from f. Okay, and now I'll be multiplying both sides by x minus y. So it is x square and x minus y equal to a times x plus y, and I'll be expanding both the sides. So x cube minus x square y equal to ax plus ay, and since we need the y to be the subject, we will be bringing all terms containing y to one side and take all the other terms to the other side. So it will become, I can write x square plus x square y plus ay is equal to x cube minus ax. Okay, so this is y I am taking as a common factor, x square plus a, and from here I am taking x as the common factor, it is x square minus a. So y equal to x times x square minus a over x square plus a. Okay, so this is what we had to show. So shown. Okay, therefore we have completed answering this question number 1 of paper 3 completely. Thank you for staying with me till the end. Please like and share this video with your friends and relatives in case you have liked my explanation, and please do not forget to subscribe to my YouTube channel. Your liking, sharing and subscribing will be really helping me a lot. We meet again very soon when we will be solving question number 2 of the same paper. Till then, bye.